Now how we go about sizing the PV array. The PV array has to deliver watt hours in the following way to the following loads. The first one is the day load, which we have called WH day. The second one is the night load. The night load is actually to be stored in the battery during the daytime. So during the daytime, when the sun power is present, the PV array has to pump this much amount of watt hours night load into the battery, and the PV array has also to naturally supply the battery's charge and discharge losses. So this is a major component which the PV array has to supply. So this would be watt hour night load by the efficiency of the battery. The third component is that the watt hour for autonomous operation. So if there are contiguous days without significant sun power, and on those days the battery has to support the load, it has to supply energy to the load. So for supplying the energy to the load on the days of autonomy, that much amount of watt hours has to be preloaded into the battery by the PV array. So taking these load constraints into account, let us work out the worst case situation. The worst case scenario will be something like this. The x-axis is the days, and let me divide that into the number of days like this. Now each segment is a day. This is day 1, day 2, so on up to day NA. NA is the number of days of autonomy, meaning NA is the number of days, contiguous days, when there is no significant sun power. So these are the days of autonomy, and immediately following the days of autonomy, you need to replenish the battery. The battery has to recuperate. So following those days from 1 to NR, these are the recharge days. These are the days on which the battery has to be recharged such that the watt hour lost during these days of autonomy is recuperated, is replenished. The watt hour lost during the days of autonomy is, let us say, given by WH auto, and the entire WH auto may not be possible to be replenished in one day. Because in such case the PV array size has to be extremely overrated, and then such a system can be costly, and that may not be worth having in such a huge PV array size just for this extreme worst case. So what is generally done is, whatever energy is lost WH auto, we will try to recuperate it spread over few days, and that is NR number of recharge days. So on each day the PV array has to supply an extra amount of WH auto by NR. So this it has to do for NR number of days, then all this energy lost would have been recuperated. So this WH auto by NR has to be replenished to the battery each day following the days of autonomy. Now this WH auto by NR is what represents this watt hours for autonomous operation. This is the component which has to come from the PV array. WH night by efficiency of the battery has to also come from the PV array, and the watt hours for the day obviously has to come from the PV array. Taking all these things into account, let us now write down the watt hour PV requirement, which will be like this: watt hour PV, watt hour day plus watt hour night by the efficiency of the battery. This is the standard requirement where the PV has to supply the day load plus the night load plus the battery charge and discharge losses. Apart from this, it has to supply the energy required for the days of autonomy, which is watt hour day plus watt hour night. So when the sun power is not there, both these has to be stored into the battery, and therefore you have the efficiency of the battery coming into the picture, and this much amount of the power for Na number of days, so many number of days. So this would be the total power that has to come out of the battery when the PV is not participating due to poor light conditions. So these are the days of autonomy, and this figure here, this equation here, represents WH auto. And for recharging, the worst case condition is, apart from this, the PV has to give immediately following the days of autonomy this much amount of extra charge, which is WH auto by NR. So this much divided by NR. So obviously you will see that this part of the equation represents the energy WH auto. So now rewriting WH day load 1 plus Na by efficiency of the battery, and then NR. So this comes from taking this along with this part of the equation. Taking this part of the equations, you will get WH night plus NR plus Na by NB, efficiency of the battery to NR. So this would be the equation for calculating the watt hour of the PV. So the Array peak watt can now be calculated. PM should be greater than watt hour of the PV divided by H hat minimum. So now you have to find out what is the H hat minimum, that is the incident energy at a place on a tilted surface with atmospheric condition, the minimum over the entire year. This we know how to do. We have also developed the necessary program files for that. You feed in the latitude and the tilt, and you will get what is H hat minimum. So for Bangalore, we found out that it was around 4.58 kilowatt hours per meter square per day. So WHPV by H hat minimum, and here this H hat minimum is having the units of hours and not kilowatt hours per meter square per day, because we are numerically using the value of H hat minimum to represent so many hours of 1 kilowatt per meter square radiation standard insolation. So H hat minimum here will numerically be same as the hours of equivalent standard insolation. And then we calculate the intrinsic area of the PV panel, which is PM by efficiency of the panel. And the real estate area, the actual real estate area, which includes even the walking area, the walkways and the service area, maintenance area, will be 1.3 times the intrinsic area. So these are the equations that will be used in sizing the PV array. Note that if Na is equal to 0, that is the number of days of autonomy is equal to 0, and there is no recharge number of days, then the watt hour PV is given by just the first part of the equation, which is watt hour day. It has to supply the day load plus the night load plus the battery charge discharge losses. Now let us try to apply it for the example that we have been discussing. Previously we discussed it for the battery sizing and also for load profiling. Recall that we had discussed about this load. You had load 1, load 2, load 3, and we had calculated the day load, watt hour a day, 612 watt hours, night load 914.4 watt hours. Let us use these two numbers and try to calculate the PV array size that is required. The watt hour PV is equal to 612 watt hours for the day load, 914.4 watt hours for the night load, plus you have to include also the charge discharge losses. So we have the 0.7 or 70% battery efficiency, and all this works out to be 1918 watt hours. The array peak watt PM should be greater than 1918 by H hat minimum, and H hat minimum for Bangalore we have found it to be 4.58 kilowatt hours per meter square per day, and here we are using it with the unit hours. So many hours of 1 kilowatt per meter square insolation. It will give you 418.8 watt peak or 0.42 kilowatt peak. Now select a PV cell from standard manufacturers. Select a 16% efficient monocrystalline PV cell, say for example, and if we calculate the intrinsic area of the PV panel, it works out to be PM by efficiency of the PV panel. Of course, if PM is in kilowatts, then in the denominator the input is 1 kilowatt per meter square incident insolation. But if PM you take it in watts, then the input insolation you should take it as 1000 watt per meter square. So accordingly use the units. So if you are using 418.8 watt peak as the peak watt, divided by efficiency 0.16 into 1000 watt per meter square, you will land up with 2.6175 meter square as the intrinsic array area. The actual area of the real estate will be 30% more than the intrinsic area of the panel, and that we have discussed earlier that it is needed for maintenance purpose, cleaning purposes, and 1.3 times 2.6175 works out to be 3.4 meter square. So 3.4 meter square of area should be made available on the rooftop so that you can mount arrays, PV arrays having a net array peak watt capability of 418.8 watt peak or 420 watt peak for this particular application. So this is how you go about selecting the PV array size.